You can see in this graph on the top there is a computer, and then you need a BCM, that's the main controller, and down there you need a DDC controller, that's your field controller and field devices. All these DDC controller, they are connecting with each other in a daisy chain fashion, and then all the signals going to the BCM. From the BCM, it connected with the LAN to your computer. Okay, and actually, why we need this BMS, building management system? Actually, it controls heating, cooling, water system, fire system. All is controlled by the program automatically with the help of this controller. And if we in the field devices, there will be some actuators, pressure sensors, temperature sensors. All this instrument will be connected to the controllers. All the programming and logic stores in the BCM, and VLCs works like PLC cards, IO cards, and one VLC could have a different inputs, outputs, analog input, output, and binary output. And to program this BCM, they use a backtalk software, and there is a Visual Logic and Microsoft View. Okay, and then the next is networking and addressing. Okay, now here you can see these two VLCs are connected in a BACnet master slave token passing. I zoom it a little bit. Okay, so now here these are connected with each other. This bus are connected with each other. Now it's a positive pin number 9 is connected to the other VLC pin number 9 positive, and the negative is connected to the negative. And from here it goes to the BCM, and from the BCM going to your PC. And on the network, for example, if you have more than one VLCs connected, then important is the addressing. These are these dip switches. These are for the MAC address, because possibly there is maybe one valve is connected here with the second VLC, and on the first VLC maybe it's opening any or running any pump for water pump. Now somehow the PCM need to know when it sends the command, it must need to know the address so that that output can be switched on or off. How we do the addressing? For the addressing, you have to set these DP switches. For example, now this time this is a number 1. Now you want to address as a device number 2. First will be off, and then only 2 will be on. And If you want to address for the 3, 2 will be on and the first will be on, then it's number 3. For the number 4, all will be off, only number 3, third one will be on. And you want to address for the 5, number 3 will be on and 1 will be on. That's how you set the address. Need a step down transformer to power up the VLC. This step down transformer is 220 to 250 to 24 volt AC, because this VLC required a 24 volt AC, and the second pin is ground. So the first one is coming from the transformer positive, and that's the neutral. And the capacity of the transformer is mentioned in a data sheet. Okay, technical data for the power 24 volt AC 5 VA minimum, and plus binary output load is 53 VA. So at least you need a 53 plus 5, 58 VA, the capacity of the step down transformer. And now we will see how to connect to a analog input. Now this device have a 4 analog inputs. That's a configurable 0 to 10 or 4 to 20 milliamps, and it has a 4 binary output and 4 analog output 0 to 10 volt. Now for example, you want to connect to a actuator or a motor that is giving a feedback 0 to 10 volt. Now it will give a feedback accordingly the position, is it fully open or is it halfway or is it 0%. It gives accordingly 0 to 10 volt. And assuming you have one transducer, it's a 4 to 20 milliamps, and pin number 2 or input 2 is configured for 4 to 20 milliamps. Now here you can see pin number 8. Pin number 8 have a 20 volt DC output that you will connect to the your pressure transducer, and the other wire will come into a pin number 3, pin number 4. No, basically pin number 3 for input 1. So that's how you measure a 4 to 20 milliamps or a 0 to 10 input. In this diagram, analog output is connected to the actuator. Output 0 and comms. These two wires are going to the actuator. It supplies 0 to 10 volts according to opening or closing that actuator, that valve. And this last one is a binary output. So this is not a relay contact. This is a binary output type. What it means, I can check in the datasheet. Binary output is a 4 output, each rated at 24 volt AC, 0.5 ampere. So it means when is active, that output 1, there will be 24 volt AC going out. So you might have a 24 volt AC relay or a contactor that is switching a motor or a pump. And now we will see some practical. So I have only VLC 444. I don't have BCM right now. Now the question is how to connect VLC direct to my PC. So I just used a a USB to RS422 RS485 connector. That converter VLC is connected to the my PC through that converter. That's the only way you can direct talk to the DDC controller without BCM and the backtalk software. If I can show you, there is this VLC 444. This green wire, this is connected to the pin number 9. It's a positive A, and this the other yellow wire is connected pin number 10 is a minus, and on the right side is a red wire is a 24 volt AC. I'm using a 50V step down transformer, and blue wire is a 0 volt. So that's how this device is connected. And now we will connect to the VLC using this software. This is a free software. Yet another BACnet Explorer. For the connection, just go add a device, and here I will choose a BACnet MSTP over serial. I have a COM8 and baud rate will be 38400, 127, 127. Max frames are 1. Press the add button. Now you can see it's getting information from the VLC 444. Okay, because I was connected before, so now it's just adding other device. So I'm just going to delete all these devices, so there will be only one device. So I have deleted the other device. Now I have only one device. If I connect to the device, if I click on device, there is the detail for that VLC. Okay, so now what I want to use first analog output. I will just click on this one and subscribe. Interval is a 5 millisecond. This is the output 1, output 2, 3 and 4. So I have subscribed the output, 4 outputs. So what I have done here is a pin number 19. I have connect my multimeter positive lead, and the 20 is a negative. If I can show you here, so positive is connected analog output, and that negative is black lead is connected to the COM, and this time you can see on multimeter 0.5 volt. Why 0.5 volt? Because just click on the left side. select the output 0, and here is your present value. Now if I override this value, I type 0, enter. Now you see multimeter goes to 0, and these are scaled 0 to 100%. Type value 10. Now you see you have almost 1 volt, exactly 1 volt. There you can see the precision also. If I type 20, and you can see it goes to 2 volts. Okay, 50, 5 volt, and 90 must be 9 volt. Yeah, 8.99. Finally 100% must be 10 volt, 9.99. And now let's see analog input connection. For that purpose, what I'm doing, pin number 19, I'm going to connect one wire from analog output to a pin number 1 analog input. Why? Because pin number 1 analog input is configured 0 to 10 volt. So I'm going to write on that output, and I will connect back into a analog input. As you can see the wiring here, from this pin I take this wire and this connected to the in one. Let's go to a program. In this program we will subscribe a analog input 0. Five millisecond, and you see there 4095. Why you are seeing this number? Now 4 universal inputs with the 12-bit resolution. Now for the 12-bit resolution you get this decimal number, because now it's 100%, so there is a 10 volt has applied on analog input channel 0. Okay, let's change a analog output. Now it's a 10 volt. Let's change into a 50%, so it will be 5 volt, and then we will see the effect on analog input. So now it's a 50%, and you can see that value has been changed. For binary output test, I have connected multimeter positive lead to a binary output 0, and the black is to the ground. As we can see there, positive is connected to the output and black is to the ground. And if I can show you this time, there's a 25.9 volt on the first binary output, and there is a light is also on, you can see there. And I turn the knob to the AC voltage side. Okay, let's go to the program, and now I'm going to subscribe a binary output 0. Just Click on that. Here is the value. The value is a 1. So it's a boolean, it will be 0 or 1. If I type 0, press enter, you can see it there immediately. It's going to the 0. So that is your binary output. If I type here 1, press enter, you can see there is a output active.